All right, let's start the next lesson. The next lesson is about computing the HCM and the LCF. So I'm just going to give it the title HCF and LCM. So say HCF and LCM. Let's green. And the objective is to compute the HCF or LCM of two or more positive integers. All right, so that's the objective for today. And the first one we're going to start with is computing the HCF. Now, the HCF is called the highest common factor or the greatest common divisor, and it's simply the largest positive integer that divides two or more integers without leaving a remainder. So I'll write that note here now. The HCF is the HIGH, no, I should write it as HIGHES common factor, aka greatest common divisor, or in other words, the GCD. Let me just put a comma here. Right, is the largest positive integer that divides two or more integers without leaving a remainder. Right? And there are usually about two methods that I would teach to calculate the HCF. The two methods I will use to calculate, I shouldn't say calculate, I should say use to compute the HCF are, first one is prime factorization, and the next one is division method. And what I'm going to do is I'm going to explain both of these methods here so that you'll be able to have an understanding of both methods, and you just simply choose the method that you find is best. However, my personal preference is the one with prime factorization. Your choice is yours. Let's see. So prime factorization is going to go first. Prime factorization, and you have a few steps that you need to do to follow the prime factorization method, about 3 steps, and let me just state those first. So you want to factorize each number into its prime factors, right? And then you want to do an identification, identify the common prime factors, and then the last one is to multiply the common prime factors to get the HCF. Right? And we'll do that with an example. We'll go through that explanation with an example right now. So let's say, for example, we're required to find the HCF of 18 and 24. So the first thing we do is we write out the prime factors of each. So we do the prime factorization first. So we start with 18, and the prime factors of 18 are as follows. We have 2 multiplied by 2 multiplied, not 2, it's 2 by 3 by 3. Yeah, right? Because in this case, 2 by 3 is 6, and then 6 by 3 is 18. But notice we can only allow to break it up into prime numbers. All right? So we state the three numbers that need to multiply by each other to get this number 18, which is 2, 3, and 3. Another way that we can write this is in an exponent form, which is 2 times 3 to the second power. Right? So in other words, we have 1, 2, and 2 3s. We can do the same thing with the next one, 24. 24. We can do the same thing with 24, and we will have 2 times 2 times 2 times 3. So let's check that. So 2 2s are 4, 2s are 8, 3s are 24. Right? So in this one, we are going to have 3 2s and 1 3. All right. Now right away you're seeing that the common factors are 2 and 3. So we have 1 2 in common and 1 3 in common. So the common factors are 2 and 3. So that means the HCF is going to be equal to 2 to the power of 1 times 3 to the power of 1, which is equal to 6. Now, the reason I put power of 2, power of 1 is sometimes it might be 3 to the second power in common. So you would put 3 to the second power times whatever, and so on and so on. All right? That's just to make the calculation easier. Prime factorization, very easy. That's why I like this method. Let's do the other method. And the other method, I think I use yellow for the labels. Yes, prime factorization. And the other label is the division method. So we say division method. And to do the division method, we again have a few steps that we need to follow. Not that many steps. Let me just put this in white. And first thing we do is divide the larger number by the smaller number. Then the second thing that we do is we use the remainder to divide the previous divisor. All right, and 3, we repeat the process until the remainder is 0, and the last non-zero remainder is the HCF. Right? Fairly straightforward to follow. Let me just, let me just select this here and bring this down a little bit. It's just my personal issues. I don't like these things above the line. It's so irritating for me. Yeah, so these are the methods, and let's look at the example. Let's use find the HCF of 48 and 18. All right, so to find the HCF of 48 and 18, we follow the principles. We divide the larger number by the smaller number. So let's see, we take the 48 and divide it by 18. All right, now with that we have 2 remainder of 12, and then we have a remainder of 12, so we take the 18 and divide by 12, and now we're going to get 1 remainder of 6. And then we do it again, so we have 6 remaining, so we take the 12 and we divide it by the 6, and we're going to get 2 remainder of 0. And then that means, hence, the HCF is equal to 6. All right, so that's the HCF there. You can test this with this one as well, let me just put this, I'll put it in yellow. All right, I'll put it in yellow. So 24 divided by 18 would give me 1 remainder of 6. And then I can say, okay, well, 18 divided by 6 would give me 3 remainder 0. So that means 6 is the HCF. And notice that's the exact same answer we have over here. All right. Next, the other thing that we need to do is compute the LCM. So those are the two methods that we would use to compute the HCF. And now we have another thing that we need to do is to compute the LCM. So let me just put that here. Compute LCM, that there. Bring that down. All right. What is the LCM? You should already know what the LCM is. If you don't remember, let me just state it right here. So the LCM is it is the lowest common multiple, and it's basically it is the smallest. I should say it means, right? It stands for lowest common multiple. It is the smallest positive integer that is divisible by 2 or more integers. All right, not that difficult to understand here. Good. And we're going to use again two methods to solve this. All right, we're going to use two methods again to solve this. One again is the prime factorization method. The two methods I will use to compute the LCMR, and that first method is prime factorization, and then the next one is using HCF. All right, so I'm going to explain both methods again, and let's do the prime factorization method. You can start to probably understand why I think that the prime factorization is the better one. I was just going up for the colors. So prime factorization, right? Bring it down to the line, and then we have a few methods that we're going to, well, a few steps that we have to follow to get the prime factorization done. And this is first to factorize each number into its prime factors. The second thing is that you're required to take the highest power of each prime factor. And then 3, we are to multiply these together to get the LCM. Right? And that's fairly straightforward rules. Let's do an example. Let's say we're required to find the LCM of 18 and 24. All right, now I choose these values here because I want to use them again with the other method, since I already calculated the HCF for it, which is this 6, and this other method here, which is using the HCF, I would need that value. So I'm just using the same example as before, and I'm just going to use the same example for both, so you can see that they are the exact same result. All right, so first prime factors, so we say 18 has prime factors. Now we already know the prime factors of 18 and 24. We have 2 by 3 to the second power, 2 to the third power times 3. So 2 times 3 to the second power, and then for 24 it's 2 to the third power times 3. Now remember, what we want is the highest powers, right? Highest powers in each. So for 2, highest powers. All right, so for 2, in this case the highest power is 3, so I'm taking 2 to the third power, and then I'm multiplying by the highest power of 3, which is second power, so 3 to the second power. And I just simply multiply those two and I'd be able to get the answer. So 2 2s are 4, 2s are 8, so 2 to the third power is 8. And then 3 3s are 9, so 3 to the second power is 9. And then 9 by 8 is 72. All right. And that's it. The LCM of 18 and 24 is 72. Let's now use the HCF that we calculated, which is 6. Let's use the HCF, which we calculated here, as 6 to find the LCM. All right. So we have another method here, which is using the HCF, HCF. All right, make that yellow, bring it down. All right, so we're going to be using the HCF, and there's just simply a formula that you're going to have to follow. And once you find this formula, it's not that difficult. So just put this here. Put this here. So the relationship between HCF and LCM of two numbers A and B. You know what? Let me just put that in quotes. A and B is given by, and we use the formula as follows. Just change this to white and use the formula. I'll just use it in blue. Yeah, let's use orange. Let's see. So HCF of A and B times the LCM of A and B is going to be equal to, well, A times B. All right. So first things first. So first things first, we find the HCF of the numbers. All right. And the second thing that we do is use the formula to find the LCM. All right, so let's say, for example, again, as I said, 18 and 24. So example, find the LCM. The LCM of 18 and 24 using HCF. We first take the HCF of 18 and 24. So the HCF of 18 and 24 is 6. So the LCM would be equal to the product of the numbers 18 times 24 divided by the HCF, which is 6. Right? So 6 into this 1, 6 into this 3. So now we have 24 by 3, and 24 times 3. I'm just going to do this again with a little bit of explanation. So I have 2 by 3 is 6. And I have one number in the tens position, which is the 2. The 2 is in a tens position. So I say 6 with a 0. And then 4 by 3 here, 4 by 3, these two, 4 by 3 is 12. So I am going to put plus 12. I have no numbers in the tens position, so I don't need to add zeros at the end of it. So 60 and 12, and that's 72. All right? This is 72. And you can see right away we're using the formula. It's very easy. So the HCF of A and B times the LCM of A and B is equal to A times B. So if I want to find the LCM, I just need to take A times B divided by the HCF. Or I can find the HCF with the same formula. I can take A times B divided by the HCF and I'll get the LCM. But let's face it, calculating the HCF, I should say, is a little bit more annoying, so it's not usually used in that case. So I will give you a couple exercise problems, well, a couple problems to do. Let me just, I'll type it out. So I'll say problems. All right, couple problems so that you can try it and see if you can solve them. You can pause the video after I put up the problem and then look at the solution because I'm doing it right away. So find the HCF and LCM of 12 and 15. Right? So that's the first one. Let's do the solution to that. So the HCF of 12 and 15. So let's say I'm using the prime factorization method. So I'm going to say 12, the factors of 12 are 2 times 2 times 3, right? And then I can see 15, it's going to be 3 times 5, right? And the only thing that we have in common to each of them is the 3, because we have 2 to the second power times 3, and we have 3 to the first power times 5 to the first power. And the only thing we have in common is 3. So hence HCF is equal to 3, right? And then let's do the LCM. So the LCM we can get as well by just simply taking the highest powers of everything that is in common. And the highest powers of everything, sorry, not the highest powers of everything that's in common, the highest powers of everything, and then multiply them together. So highest powers, the highest powers are 2 to the second power, and then 3 to the first power, and then 5 to the first power. So then we have 2 2s are 4, so I'm just going to bring that down here, 4, and then this here is 3, and this here is 5. So 4 times 3 times 5, and that will be our answer. So this is 12 times 5, which is 60. So, and LCM is 60. All right, so that's the LCM and the HCF of these two. Let's do another one here. All right, number 2. Let's say we're required to find, let me think of another one. Let's say find the HCF and LCM of 35, 50, and 70. Right? No, these are some big numbers and I made it big on purpose so I can show you what my thought processes are when I'm solving for big numbers like this. So the first thing I do is I start with the smallest number, 35, and I think to myself, what by what can give me 35? So 5 by 7 can give me 35. 7 by 5 is 35. They're already prime numbers. That's good. I leave it as it is. Then I look at 50. 50, what can I get? So two numbers that I can get to multiply by 50. I will say 2 by 25. 2 by 25 is 50. This 25 is not a prime number. The 2 is a prime number. The 25 is not a prime number. So I think of what two numbers can multiply to give me 25. And I would think to myself that, oh, well, 5 times 5 will give me 25. So I combine these. I replace this with the 5 by 5, and I'm going to get 2 times 5 times 5, which is 2 times 5 to the second power. And then I have 70. And I will say 7 by 10 is 70, but I know that 7 is already a prime number. 10 is not a prime number, so I can change that 10 into a prime. I can think of two numbers that will multiply to give me 10, which is 2 by 5. And I know that those two are prime numbers, so at the end of it, I will get 2 times 5 times 7, right? And this will be, well, that's as it is, right? 2 to the first power, 5 to the first power, and 7 to the first power. Now I just have to multiply everything that is in common with the lowest powers to give me my HCF. So HCF would be equal to everything in common with the lowest power is 5. So 5 would be the HCF of these three. And then I would need to multiply the highest powers highest powers of each of the prime factors. So I would say that first off, it's this 5, then we have a 7, and then we have a 2. So the highest powers multiplied together would be 2 times 5 to the second power times 7. All right, let me just work that out. So 5 by 5, it's going to be 25. Bring down the 2, and then bring down the 7. And then here I will have 50, and then 50 multiplied by 7 is 350. Right? If you need to check that out, check it out on your calculator. So that means the LCM of these three is 350. Right? Very simple to do. Let's do one more, and that will be it. All right? One more. Put this over here, and we can say 3. We're required to find the LCM of 40 and 60 using the prime factorization method. All right, so I want to find the LCM of 40 and 60 using prime factorization method. Now, I've been using that method all the time. Right, I've been using that method all the time. As I said, it's my favorite to use it, my favorite to solve the problem with. So that's why I use that. And if you want to use something else, you're welcome to try. And if you have any issues, tell me. So let's see. So 40, two numbers that can multiply to give me 40. I would think 2 by 20. 20 is not a prime number, so I will replace that with 2 by 10. 10 is not a prime number, so I'll replace that with 2 by 5. And then when I simplify this, I will get 2 by 2 by 2 by 5, which is 2 to the third power times 5. And then we have, what, 60? So 60 is going to be 2 by 30. Replace this 30 with 2 by 15. I can replace this 15 with 5 by 3. And all of them are prime numbers now, so I can say 2 by 2 by 3 by 5, which is 2 to the second power times 3 times 5. Right? And all I'm doing is doing the LCM. So the LCM, we need the highest power of all the prime factors. So the highest power of all the prime factors, let's see, we have 2 to the third power here, we have 3 to the 1 power here, and we have 5 to the 1 power. It doesn't matter which one you choose. It could be this one or it could be this one. It doesn't matter. So that means the LCM would be equal to 2 to the third power times 3 times 5, which is 2 to the 4 2s are 8. So let me just put that out. 8 times 2 high times 3 times 5, which 8 5s are 40 and 4 3s are 12 with a 0, so that's 120. All right, so the LCM of the problem is 20. Okay, that's it for this one. See you in the next one.